This presentation will cover the top diseases of high tunnel tomato in Kentucky. You will notice that common diseases noted here are different from common diseases in field tomato production. High tunnel tomato are planted earlier and exposed to different environmental conditions and therefore different. Disease is the physical reaction of a plant to infection by microorganisms such as fungi, bacteria, viruses, etc. Disease symptoms include spotting, wilting, rotting, and more. And in order for disease to develop, three things must be present. So in the context in which growers listen and think about disease management on their farm, they should consider these three components of what we call the disease triangle. In order for disease to develop, we must have a susceptible host. So that would mean a plant that's in maybe an age range that infection is possible, or even a cultivar or a species that is susceptible to infection. The pathogen must be present. In other words, there must be some source of that pathogen, whether it was introduced onto the farm and has overwintered, or if it is introduced with maybe new stock plants. And thirdly, a conducive environment. So in short, and we'll talk about this later, but in order for disease to develop, there must be two things present. Moderate temperatures, meaning if you're comfortable, the pathogen is usually comfortable too, and free water. That could be anything from irrigation to rain to high humidity. So these three components must all be present in order for disease to development. And if we can break one of those components, or we can work at all of those components, we're reducing the disease and reducing the risk for disease. So we use the disease triangle to take advantage of all the tools in our disease management toolbox. Integrated pest management, what we call IPM, and in this case, integrated disease management, forces us to consider more than fungicides when we manage disease. So these tools include using resistant cultivars. So thinking about, again, that disease triangle, using resistant cultivars, managing water, whether that's overhead or soil water, starting with clean plants and clean seeds, using sanitation, keeping things clean all season, rotating crops, so not planting solanaceous plants back to back. So a 3-year rotation is ideal, especially if there is a history of disease on the site. Mulching, tillage, and or cover crops. And finally, fungicides. Often in commercial production, we need fungicides, whether that is conventional or organic production. But reducing the number of fungicides and the types of fungicides can definitely be a practice if we're integrating all of these disease management options from the disease triangle. The most common diseases of high tunnel tomato in Kentucky are different from the priority diseases in field production. These disease priorities are different because timing of infection is different and disease development is therefore different. So notice on this list that leaf spots like anthracnose, early blight, septoria leaf spot are not on the list. And diseases that are less common in the field may be priority in high tunnel. So for example, Pythium root rot, Rhizoctonia stem and root rot, timber rot, root knot nematode, leaf mold, and tomato spotted wilt virus. So none of those show up as priority diseases in field production, but these are the priority diseases of high tunnel tomatoes in Kentucky, and that's what we're going to talk about today. So let's start with our first disease, Pythium root and crown rot. So Pythium is a soil-borne disease, meaning it survives, it lives its entire life in the soil, so it survives there. And it usually infects plant parts at or below the soil line. Pythium is a water mold. It's not a true fungus. It's a water mold, meaning it needs a lot of water to complete its life cycle. In fact, the spores have flagella, so they'll swim a lot like tadpoles. So think about it that way. So more water, the happier your water molds are. There are several species of Pythiums in Kentucky soils, but in the greenhouse, we're usually limited to 1 or 2. Again, water molds require extra moisture, and the more moisture we have, the faster those pathogens can infect, the happier they are, and the more disease cycles we might see. We usually see Pythium diseases as a damping off, meaning they can infect plants before the seed germinates or right after the seed germinates. So it's usually an early season disease for high tunneling greenhouse tomato. And the Pythium pathogens that affect high tunnel tomatoes or any tomatoes usually have a very wide host range. So it's very hard to rotate out of a Pythium problem. It's more of a sanitation issue when we think about management. So here are some close-ups of some Pythium affected roots. On the right, we see the brown to tan, even collapsed roots, slimy most of the time. And on the left is just a close-up. And if you look right in kind of the center right of that image, you'll see that the cortex of that root has sloughed off and just the stele is sticking out. We call that rat tail roots, and that's usually a sign that Pythium is infecting roots. So dig or loosely shake soil or media off, don't pull, and then look with a magnifying glass or a jeweler's loupe or some type of hand lens, and that will usually tell you if Pythium is likely a problem. The next disease, another soil-borne disease, is Rhizoctonia stem and root rot. The Rhizoctonia pathogens cause stem cankers and damping off. So here we go again, some really early season diseases. Generally, Rhizoctonia affects seedlings less than 4 weeks old. This is another, it's a soil-borne pathogen. It will survive in soil. So that can be in the ground. It could be in dirty tools, dirty equipment. So anywhere that we would see soil. The Rhizoctonia pathogen that causes stem canker and damping off in high tunnel tomato is also the same pathogen that causes web blight and aerial blight in other crops. So this may sound like a familiar pathogen because it is. These Rhizoctonias have a very wide host range. And if you're going to think about rotation with that wide host range, our non-hosts are pretty much cereals. So thinking about not that we would plant cereal crops in our high tunnels, but using cereal crops as cover crops. So rotation becomes very difficult once Rhizoctonia or even Pythium has taken a hold because of their very wide host range. So here are some more close-ups of the Rhizoctonia disease, in this case damping off. On the left, we'll see a stem lesion right at the soil line. You see kind of that reddening with the bleaching in the center and that constricted stem right at the soil line. And on the right, that's damping off. So we see that constriction, that infection of that tiny seedling. And if you look really closely on that lower right-hand plant, there's some mycelia or that filamentous fungal body right there on the soil surface. So Rhizoctonia, another soil-borne pathogen that really is managed with sanitation and rotation, tillage, and by rotation, that would usually mean some fallow period, unfortunately. Our next disease, and this is definitely a priority disease for some growers, other growers maybe not so much. It's a soil-borne disease, timber rot. Timber rot is caused by the fungal pathogen Sclerotinia, which is the same pathogen that causes drop-in lettuce, white mold in beans. So diseases go by different names, but they're the same pathogen. So wide host range. The timber rot disease, or the pathogen Sclerotinia, is an early season disease. Early season meaning in Kentucky, April and May. So this pathogen likes cool soils, cool temperatures. It lives its life in the soil, just like other soil-borne pathogens we've talked about so far. And then stem cankers develop right at or right above the soil line. Once infection occurs, there's not just that canker, but what we call shredding. So the stem will start cracking in more longitudinal type cracking. And inside that cracking, you'll see sclerotia and mycelia. So sclerotia are the black survival structures of the Sclerotinia pathogen. And in the image to the left, you'll see a couple of those black sclerotia there on the surface, and they're covered by the mycelia or that filamentous fungal body. But once you crack open that stem, there'll be lots of sclerotia in there. And just a little bit of a hint, these are hard and melanized, so they're able to withstand lots of heat. They're able to survive fungicide applications, UV light, drought. So once sclerotia form, they're a long-term overwintering or oversummering structure. Non-host for Sclerotinia or corn and cereals. So again, very hard to rotate. When we have a Sclerotinia problem in our high tunnels, usually taking it out of production, unfortunately, is one of our only solutions. We'll talk more about solutions at the end. Here's a picture of that shredding. So this is a stem that was cut open, so a cross section of a stem, and inside that stem we see those hard sclerotia. They're black, very hard. They look like rat droppings. And then our last soil-borne pathogen is root knot nematodes. Now, nematodes are not similar to the other pathogens we've talked about because nematodes are actually microscopic roundworms. They live their entire life in the soil. They infect roots and are parasitic. So it's the female that infects those roots and survives there. So the galling, when we call this disease root knot, or the name of the nematode we call root knot, it's because once the female infects roots, it'll produce those galls or cyst-like galling. And what these galls do is constrict and girdle roots so that we don't have the uptake of water and nutrients into roots. So stunting and wilting is usually the symptom as temperatures get warmer because those roots are just not able to support entire plants. Root knot nematodes favor warm temperatures, so we'll usually see symptoms and most activity later in the season. They have a very wide host range, and if we're talking about rotations, their non-host are corn and onions. So again, these are very difficult pathogens or nematodes to manage once they establish in high tunnels. So again, when we think about prevention and we think about that disease triangle, once we introduce some of these pathogens into our high tunnels, they're difficult to manage, but to prevent them from being introduced in the first place, it should be our goal. Here are some close-ups of root knot nematode damage. So on the left are galled roots. As a matter of fact, that's a cucumber root. In the upper right, that's a close-up of a tomato root. You see those shiny white globules. Those are the females that are encysted in the root. And on the lower right, that's actually a sweet potato, but you see the damage, the necrosis, as that female has embedded herself into root. So imagine that that root has lost its function because there are so many nematodes in that root. All right, so let's switch gears now. Let's go to foliar diseases. Leaf mold is our first foliar disease that is listed as priority of high tunnel tomatoes. Leaf mold is a fungal disease and it likes a lot of humidity. It likes a lot of water. So relative humidity above 85% is usually going to trigger a leaf mold infestation or epidemic. Leaf mold doesn't directly infect tomato fruit, rarely does it. It's just usually becomes so severe in leaves, it just results in plant decline, overall plant unthriftiness, and a plant's inability to photosynthesize. What we see in leaf mold and what we mean by mold are just the large number of spores on the underside of the leaf. And what we see in this image, all that brownish gray fuzz, that's all mycelia and conidia or spores. So once we see this many spores and we have the environmental conditions that are conducive for infection, these spores will spread very rapidly and disease becomes really rampant. So once we see leaf mold, it always seems like it's too late because it spreads so quickly. One positive about leaf mold is that this pathogen only affects tomato, so it makes rotation a little bit easier, or a lot easier, because the host range is narrow to just tomato. Here are some close-ups of leaf mold on tomato. On the left, we see that sporulation underneath the leaf, and on the right, those are the symptoms on the top side of the leaf. Notice they're yellow, so the fuzziness and the mycelia does not appear on the upper side, only the yellowing symptoms. So flipping the leaf over is where you will see the sporulation. Okay, and our last disease for our high tunnel priority list is tomato spotted wilt virus, TSWV. You might see it abbreviated. This is a foliar disease. This virus is spread by thrips. So thrips, of course, being an insect, and so this vector is going to determine what the host range is for tomato spotted wilt virus. Once infected, leaves generally become necrotic and they start bronzing and almost blighting. In older plants, leaves will curl and dieback will occur from the tip. Now, most viruses we know will, the symptoms will be a little bit ring spotted on fruits and leaves. And if you look closely at the image here on the left, you'll see some of those ring spots, right? Almost like leopard spots. And that is indicative of tomato spotted wilt virus. Here are some additional images of tomato spotted wilt virus. On the left is a tomato leaf that has advanced in symptom development. So we'll still see those ring spots, but we'll see that blighting coming in on that leaf. So sometimes that's called bronzing. It might look a little bit bronze early on, but that blighting will occur. The ring spots on tomato fruit in the upper right, and in the lower right, symptoms on stems. Now, this can really confuse you because there are no ring spots here. So this really just looks like some other disease. So be careful as you're scouting for tomato spotted wilt virus, or if you suspect it, don't be fooled by some of the symptoms that might not be as clearly ring spot as you might expect from some of the images you might find. Okay, so those are our priority diseases, but what about some other diseases? There are lots of disease risks in high tunnels or in any production system, especially as we monoculture. So our minor diseases, and I just want to mention these in passing, our minor diseases of high tunnel tomato are powdery mildew, Botrytis gray mold, and gray mold is the same Botrytis pathogen that will affect other plants. So any of you who are tobacco growers or greenhouse growers, that same Botrytis can infect tomatoes. That is also a pathogen that likes a very high relative humidity, so 85% and above relative humidity. So bringing that relative humidity down will help manage gray mold. Southern blight. Southern blight is a hot weather, warm soil disease that we'll usually see later in the season, usually August, September. We can see it in July if temperatures are warm enough. So that is the image on the right here, southern blight. So if southern blight has been a problem in your high tunnel, it will be back. That pathogen has a wide host range and it is difficult to manage. So if you have southern blight, you will know it. And if you don't have southern blight yet, that's excellent, and be careful not to bring it in. And then finally, Fusarium wilt, we see it on occasion. It is not as common in Kentucky high tunnels as you see it, say, in the Gulf South, but we do see Fusarium wilt on occasion, and that pathogen is another soil-borne pathogen that, once established, is difficult to manage. So let's talk about management in general. Okay, so we're going to go back to that disease triangle that we saw at the very beginning. And we're going to think about the three things that we need for disease to develop. And so we need a susceptible host, pathogen must be there, and we must have an environment that's conducive to disease development. So how do we manage with that knowledge? Well, we think about how we can alter the host or the host species or the host cultivar. If and how we can eradicate the pathogen or prevent it from coming into our high tunnel in the first place. And then thirdly, manipulating the environment. And usually that has a lot to do with water. So with that knowledge and with those concepts, let's think about disease management in general for all of these tomato diseases. So we'll start with altering the host, right? So in order to alter the host, we can think about using resistant cultivars. So if a disease has been historically prevalent in your high tunnel, looking to see if there is a cultivar that has resistance or tolerance to that disease. So keeping notes, always keeping notes, very important. We can also think about planting early to avoid some of our warm season pathogens. So that might think about southern blight, right? So if you plant early so that you can terminate the crop before southern blight might become a problem later in the summer. Or on the flip side, planting late so that you can avoid some of the cool season pathogens. And that includes like Botrytis gray mold and of course the timber rot that we talked about. So timing of that host will make a difference. Next, eradicating the pathogen. Let me say though that eradicate is a big word that that's really not possible. So we're never going to really eradicate. We're going to suppress, we're going to reduce, and we're going to manage a pathogen. But once a pathogen is established, we're not going to eradicate. But we can start by bringing in clean, disease-free plants and seeds, so not introducing the pathogen from the start. Once we do have the pathogen present, we can prune dead, dying disease tissue. We can rogue any diseased plant if necessary, if it's a disease that cannot be managed. Solarization, so Dr. Rachel Rudolph and I have done a lot of work with solarization in high tunnels, so I'll link that information below. But solarizing in high tunnels for soil-borne pathogens is a really great way to not eradicate, but drastically reduce pathogens in high tunnel soils. Always rotating, 3-year minimum, rotating into crops, non-host crops. And I know that's tough. High tunnels are prime real estate. They're our highest money makers, and tomatoes are generally our most profitable crops in high tunnels. But thinking about rotating, especially once you have an established disease that cannot be managed by other means. But making a habit of rotating before there's a disease outbreak will prevent the large buildup or the excessive buildup of pathogens, especially soil-borne pathogens. And when we talk about sanitation, we think about not just pruning and roguing plants, but also clean picking. So any fruit that's infected should come out. So when you pick 2 different buckets or bins, all of the diseased fruit goes into one bin and then the marketable fruit in another so that you can discard. So never leave diseased fruit in the high tunnel, never throw it on the ground, never throw any of your cuttings on the ground. And finally, tilling, so tillage after plants are terminated and everything is removed. So tillings to bury any of those last little residual debris that cannot be picked up. And if you're in a no-till system, putting a cover crop in. So while we're talking about managing or eradicating the pathogen, I need to mention fungicides. So this is a very quick note about fungicides. We have lots of other resources on fungicides. So really quickly, fungicides can have active ingredients that we call either conventional, and those would be synthetic, or organic. So in general, conventional fungicides usually are really advanced. They can be systemic. They can be very selective to certain types of pathogens. Rain fast, meaning they won't wash off with overhead irrigation. Organic products are usually naturally derived, and organic growers, they're certified organic growers, are generally aiming for something that's OMRI approved. Timing of fungicides is very important. So we use fungicides as preventative treatment. So knowing what was in your high tunnel last year, knowing what your risks are, and then using preventative treatments. Now, I'm talking about fungicides specifically here, but of course, across the board, preventative practices are really important. After disease breaks out, any fungicide application at that point is going to be suppressive. So fungicides will not cure disease once it occurs. It will only suppress. There are different modes of action of our fungicides. So we classify those into what we call FRAC groups. So those are fungicides resistance groups, and we rotate FRAC groups. So if you don't know what a FRAC code is, look down in the description. I will have some additional resources there. And again, translocation, and that's how the pathogen, that's how the fungicide will move within a plant. So that mode of action can be locally systemic, and that means it will move maybe within a leaf or within a branch. Fully systemic, that means that the fungicide can get into the vascular system, into both the xylem and phloem, and the fungicide can move both up and down within the system. And then, of course, there's contact fungicides, and those will only manage the pathogen that it directly touches. And one final note on fungicide use in high tunnels is that in Kentucky, high tunnels are considered greenhouses, so assuring that fungicides used in the greenhouse either are labeled for greenhouse use or greenhouse use is not prohibited. So other states may have different interpretations of those rules, but in Kentucky, greenhouse use must be allowed on a fungicide label in order for it to be used in a high tunnel. All right, let's get back to our disease triangle. So the third component of the disease triangle is manipulating the environment, or that's our approach considering the disease triangle. So how do you manipulate the environment? Well, air circulation. Air circulation will dry out leaves, and it will lower the humidity. It will lower the free water that most pathogens need to complete their life cycle. So spacing plants within a row, spacing rows, trellising and tying, pruning and trimming, anything you can do to increase air circulation and dry out that air. I also am really aware that humidity in greenhouses is always really high. So having a humidity meter in every high tunnel, very important. And being able to exchange the air. So as long as temperatures are above 50 degrees Fahrenheit, sorry, that C is supposed to be an F, above 50 degrees Fahrenheit, you can exchange that air. So opening end walls, opening side walls, just enough to exchange to let out that excessively humid air and let some lower humidity air back in. And usually that is happening early in the season because high tunnel tomatoes are planted early. That's the benefit of high tunnels. So early in the season to be able to exchange that air as often as possible on a sunny, warm day, for example. Okay, so finally, think about resources. So this was a lot of information, a lot of detail, and then of course, some detail we were just not able to bring in today. So looking for resources, Kentucky specific resources, going to our website, plantpathology.ca, that means College of Agriculture, .uky.edu will give you lots of resources on diseases of not just tomatoes, but other vegetables, fruits, specialty crops, etc. You can find scouting guides at veggiescout.ca.uky.edu, and those are essentially picture books. Those are references. And any of our social media at KY Plant Disease, so you can find us on Facebook, X, and more. And just specifically, you'll see the image on the left that is a new series that we have just come out with. We have spray guides, cultural calendars, and we even have a series on organic spray guides. So check those out.